Welcome to a Sunday evening. I've been playing around with TFT displays, like these guys, this guy, this guy, this guy, this guy, and I got some of it working. My original goal was to actually get this guy working, because it has a dedicated port for it. But this was not working the way I expected, and I had to switch plans. So I've got a new pink Pico. I've got the other Lowland S3 in here, the one without the connector. And then I've got an ordinary Pico right here, I haven't done anything with yet. And I had some interesting stuff with this particular display. Okay, so one of the things that has come up with the Visual Studio Code and the extension for Circuit Python, there apparently is a bug. For people first using it, it might be a showstopper for you. It's kind of weird. The issue is when I plug in a board like this, for example, and I've got it displaying on the screen in the lower corner, and I go and open the folder Circuit Python. Now this part all seems to be working. It goes off, it builds the .vs code directory, the settings, and all that stuff. And you can see in the lower corner, right here, the bundle update to 2024-01-27. So normally what you do at this point of view is once it's done setting itself up, you choose a board. And what was happening, you click choose a board, and this is a clean install if you did this. It wasn't working. This was failing out. Okay, it didn't let you pick anything. You couldn't connect to the serial port. You couldn't choose libraries. You couldn't pick a board, anything like this. I'm just going to pick the board right now because I know I want to use Raspberry Pi Pico. So a few more things are put into the .vs code line. Let's go have a look at settings. So normally it starts off with just the top block like here. I'm going to just switch screens here to desktop. So normally, and it adds this section here, this lower section. It's still, if you have an existing one, it doesn't update the date, this guy right here. You have to do it manually in two spots, here and here, based off the message you saw in the lower corner here. And this, you never know when they update the bundle, right? So you have to tell it. Now, the weird thing about all this, is that if you create a workspace file, the workspace file gets this updated all the time. It's just the settings.json that doesn't. Now, since it wasn't picking a board or anything, none of this was getting filled in. One guy on the Windows side wrote in the GitHub, he tracked it down to one problem on the Windows side. If we bring up our file explorer and we go looking at here and we go find our .vs code directory here, extensions, and there's the two extensions, 2.0 and the 1.20. So the easiest solution was to flip back for the moment to the 0.1.20, but the issue was in here and in here. And if we scroll all down to the board, there's this metadata JSON file. Think of it as like the master index for all the boards. Problem was, it was missing. At least in the Windows' bundle, missing. I cannot confirm this was missing on the Linux side when I had the problem, because this machine with this layout and everything had the error that it wasn't working. But my VMware, as soon as I installed 0.20, no problem. It worked perfectly. Now, some people thought it might have been the Visual Studio Code 1.85.1, right? But no, that wasn't it either. I'm more guessing that it was because of this was missing on the Linux side. Now, I am in the habit of rebuilding my boards and stubs right away. Yes, I know the bundle puts its copy in and everything, but I don't trust it because by the time I put the bundle in or get it from the site, that's already changed because new boards have come out. So I go to my build directory and I rebuild the boards and stubs that I've demoed in another video, right? And then I copy boards and stubs over. So at first, when I encountered this initially, when a brand new copy of 2.0 was put in, right? I suspect I was missing the file also from the Linux's point of view. But of course, as soon as I replaced boards and I replaced stubs, the file was created because that's part of the build process. And I had no trouble after that. So just be aware, if you get that issue, you can go to extensions over here and you can find the Circuit Python one here. There's two ways to do it. You could right click here and say install another version, or you can go up here and say install another version. Either way, you'll get the list of versions and you can roll back to one. Nothing will go wrong. It'll work. And as far as I know, it's not the version of Visual Studio Code, because when we jump to 1852, which is the current one, no problems were there. So just be aware of this when you're using this. Don't give up in frustration because it just doesn't work at all. Usually it's things like this, and as I said, the debug console told the Windows guy it wasn't loading a file, and it so happened to be a critical file, that meta list. So back to our boards, and I'm going to switch back to so you can all watch it there. So I haven't put anything on here. So this one here is the S3, ESP-S3, and this one here is the Pico. Now, if I take this guy here and I plug it in, you can see the display is working. Let me mount to this Circuit Pi drive. I have to remember it's number 2 per Circuit Pi drive. I don't need the settings JSON anymore in the corner here. So I know there was some stuff. Oh, I was starting to do something on here, but I just never completed it. Yeah, we'll worry about it later. I need another window. View. Can I have another window? Can I have another window? File. Can I have a new window? Yes, I can. There we go. Another window. You don't see this simply because that little corner window is one Visual Studio Code. I guess I have to go back to desktop for a sec. When I was first doing this particular TFT, that one, I could find the right camera. This happens to be a what they call a nomem underscore TEC version 2.0. On the back it says driver IC ST7735. So there's a couple of ways of getting access to this. The big library, of course, is Display.io that writes all this stuff to the screen. Let's see if I can actually add another VSC. No, I know what I'm going to do. We'll close this one. File, close folder. Oops. And I didn't mean to actually close all of Visual Studio Code. Do I still have it available on Basic? Yes, I do. So in this one, we're going to open this one, the second Circuit Python directory, this guy here. Now you see the bundle is updated in the corner right there. The message is 0127. So if I click on the code Pi file, I might get a import error from board. I can't find board. Luckily, today it's working. If we look at the .vs code settings, this is the funky thing. It does say in here, open the workspace. Yeah, that's fine. It say 0127. So that is yesterday. And I know I didn't open this yesterday, but we can see in the settings.json that it updated. This is, I wish he would fix this. This is just drives me bonkers at times. Sometimes this line gets edited, sometimes it doesn't. Yet the workspace version of the file, this one, always gets updated down here. No problem. But the settings, original settings.json doesn't, and I don't know why. If the date gets out of whack, the symptom is right away red squiggly under usually the board or one of the other functions, the Python imports. So all you have to do is just do that, and all of a sudden the reds will go away. It's not that your code is broken or anything like that. It's just that it can't seem to find the reference to those. Now, when I originally did this screen, it was upside down. So I wanted to turn it, actually, let's back up even a little farther. When I first put this on, it was blank and white. And you're going, well, why is it blank and white? Well, there are three 7735 chips. The 7735, the 7735R, and the 7735S. And at first I thought I had, when I did it on the ESP, I had it wrong. Like, I mean, I figured I wasn't doing something correct. So this particular display down here, this one, this is an actual Adafruit display. There's a microcard thingy in here. You can see the Adafruit writing and all that. This is one of their products. This, of course, which is this guy, is a knockoff clone, whatever you wish to call it. But they're popular out there. This particular one is easily bought, and a lot of suppliers have it. So when I was looking at that, and I was looking at the driver for it, and I kept fiddling and fiddling, couldn't get it to work. Then someone suggested on the forum, maybe this isn't the 7735. That's when I realized there was a 7735R and an S. So when we look at the code here, that one right there, that's the R's version, and that's the non-R version. Now, I also found out that these two imports are what they call boilerplate code. Now, meaning that if I go back to Adafruit's site about this, let me see if I can. I think I have the tab open for this. Yeah, I do. So let me go to the web page for a sec. So this is the R code, for example. The real key to this code is this init sequence. It used to be you had to send that init sequence yourself. So what they did is they wrote some boiler code into here to do this. It sets up the display, sets all a bunch of stuff up. You can see it in the notes in here, you know, blah, blah, blah. Right? I don't understand 3/4 of what it's really saying, but the init block for this R is not the same init block for the non-R. And this was listed as a non-R. So when I changed the code to R in the thing up there, I mean, I had both of them imported, but you can see that the second one here is grayed out. It's kind of a lower color purple. It just simply means it's not in use at the moment. There's nothing stopping you from loading both of them and then flipping back and forth between them. You just have to remember that wherever they call ST7735, like down here, you call the right one. So the non-R or the R. Otherwise, all the code just stays identical, right? So as soon as I put the R in there, all of a sudden I had it, but it was upside down. And I couldn't figure this out. So I went back to, let me find it again. Not you. Not you. Okay. this guy here. So if we go back to our web again, so I was after the display IO component of it because I figured that's how you're going to rotate it in there somehow. So introduction, yeah. So display IO, has a way it works. So you set up your display, you make a group up. In the group, you do a tile grid. Within the tile grid, you do a bitmap and palette or other things you might do to the tile grid. And one of the things in the tile grid I was after, right? Here's tile grid, right there. Here's all the parameters you could pass to tile grid. But guess what? That's not all of them. There's all this stuff in here. Flip, and what I was after was this transpose. I figured that I could just, run a transpose and change the XY from one corner, which I believe was, when it was upside down, it was the top right, and I wanted to make it the bottom left. So the 0, 0 coordinate, right? And I thought I could do that. I couldn't get it to work. I mean, I defined the object, I had it, it's a Boolean value, but I could not seem to modify anything and add the modification to TileGrid. I couldn't figure out what was going. So I went back to Adafruit about this on the Discord, and a fellow named Dan H says, go higher up in the model and check it from the display point of view. Instead of doing it from here, do it from here. That kind of made sense. Because if you look at the code, right, display bus, display O4, display that object, this thing we're creating here, blah, 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 we set it all up, okay? But then I ran into another issue. When I go and find the database for display, and let me find it, I can find, house display IO, so I need to search for, oops. Yeah, give me a moment here. This is a tricky page to find. I wish it was done better, but it is not. Adafruit docs. ST7735. Okay. So this guy here, for example, is the ST7735 version of the doc. And you scroll down into it, like so, sample code, blah, blah, blah. What we're after here is the API reference. So I'm going to go to the API reference. See if I get this right. Introduction, was it in there? Usage, documentation, content, okay, yeah. I really wish sometimes these docs were organized a bit better. I'm looking for. Come on, where is it? It should have been in here. Not the usage example. Not this one. Let me see if I can find it by the R's version. Yeah, right here. This is what I was after. They both have this, but you can see there's no the consistency in the documentation isn't quite right. So I was looking at this and this right here. Let me see if I can zoom in a little bit. There we go. Um, and I could see here, 4 wire, and I saw that being set in the code. BGR false, invert false. But I was interested in this little funky chunk right at the end here. From a C point of view, it implies to me that you have an open-ended parameter list that you could be sending to this. But when we go back to the code for this, I think I have the code for it open on GitHub, right? And we look at here, there's the code for that init right there. We're defining the blah, 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 and all that stuff setting. There's our KW args. Here's the init sequence, blah. Okay, we sent if BGR, we're checking for that. Else, we're checking for that. Like we're changing one init sequence. And then the invert, and that's it. Okay, where's the rest of the functions, right? Because if we go back to their code for the sample, and we do the sample test, and it happens to be a 128 by 160, by the way, and we look at the sample code, where are they getting rotation from? It's not listed anywhere, right? Can't find it. Now, something gave me a hint a little bit about this. Now, when I went looking back at the GitHub a little bit, I noticed this right there. The class ST7735R bracket bus display bracket. So I'm not a Python expert on this, but from a C point of view, it's like you're sending it a function of another function into this function, right? So that means that within the scope of this function, you should be able to call stuff in that function. That's what my brain was saying, right? Which would give an explanation of why I was seeing parameters like rotation in here, and I was seeing others too in other sample code. Um, this one here had rotation, the simple test, 128.6. Here, color start, right there. Where did that come from, right? Well, when he gave me the hint about this, I thought about that bus display, right? That was showing up in there. There's the display. Oh, bus display, right? And then I realized that's how you originally did some of this stuff. There's that init sequence again, right? Not particularly for this display, for example, but for a display. So I'm looking at this, and bus display has all these parameters. Da, 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 da. Right? So I'm getting used to the idea that this boilerplate code basically is getting more stuff out sent to it than what obviously looks like from the code. So if I go back to here, so I dropped in rotation 180, reran the code. Sure enough, I flipped the display around. Now I also noticed that within display.io.display, so bitmap, here, sorry, web. These are all the stuff you can use in display.io, color converter. Aha, that's interesting right there. That code looks familiar. That looks like the display bus code. right? I mean, cut and paste for it, and there's all those parameters again, right? All within display.io.display. So it's looking like originally you used the display bus to do set things up, and then I guess they're in the migration process of merging some stuff together so that it's all in one super library. And then with the boilerplate code, I suspect they can sit down with displays and just simply write new boilerplate code, include that stuff in it, and guess what? You got all these other stuff you can do with it. It should work, right? So once I had that figured out, things went fairly easy. I had, um, oops, let me just go to code here. Desktop, basic, there we go. So I had no problem getting this working, right? So if we go to our Visual Studio Code for a sec here, and I'm just going to close the workspace, like so, and bring File Manager up. And the second Circuit Pi, I'm going to safely remove. Unplug this. Now, unlike the actual, I think ESPs, no, this one's Visual Studio, sorry, USB-C also, so you can see on this display, I knocked it. Well, I just broke it. Did I? Well, let's try again. Let me put it in the bottom one. There we go. So this is the Adafruit one, as I said before, and I got it working on the Lowland, no problem. So there was another display on the net, this guy here, this red one. These are also, apparently these little guys are very popular. This one also is a 128 by 128 display. So I've put some wire on it and a connector. And we're going to use this Pico to do everything. Okay. So this particular one, I haven't mounted its Circuit Pi drive, so I can safely unplug it. So I'm just going to move these out of the way for a moment so that we have this one. Now I might try also this one. Okay. Oh, I do need something from the code on the pink Pico. So just a sec. I want the file, the code.py file, off it. So let's go. And did I put a dot? No, I didn't. Okay, that's good. So we'll copy this. And in this Circuit Python, we'll delete this and this. We don't need them. And we'll paste our one file here. I just want to mess with existing code. So, okay, so this guy here, let's just simply go to the home tree so that I can safely remove. There we go. So I'm going to have to use this guy, kind of a wiring reference for this guy here. So what we need here is to wire all this. So we'll start with VCC. And we need the 5-volt line, which is VBus. And then we need the red line, which is ground on this thing. That is skip a hole and next one in. Then we need SCL, which is the orange wire, and I was sending it to orange wire 1, 2, 3, 4, 5, 6, 7th in. Orange wire, 7th in down here. 1, 2, 3, 4, 5, 6, 7. Did I get the right one? That was the orange wire. That was, oh, CS. No, that probably isn't the right wire. CS. Where did we send CS to? CS was the white wire, and it was 4th. So I need 1, 2, 3, 4. That's the CS wire. The next one is the reset wire. On this one, it's yellow. And on this one, the reset wire was blue. And it's 2. So yellow goes to 2. Like so. And then we've got the next one, AO, which I believe is the DC. Because they're not all labeled exactly the same. DC is yellow and it goes to 1. And this is green and it goes to 1. So. Okay, that leaves 3 more wires to wire. Okay, so SDA, which on this one is green, and it goes right beside the orange. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 green SDA. And that one is blue on this one. 1, 2, 3, 4, 5, 6. And then our next one is a clock. So we need a clock, and on this one, that's SCL, and that's orange, and it goes 1 above that. So this one is purple, and it goes 1 above the blue. Okay, that leaves the last one, which is LED, which is the backlight for the thing. So backlight was green, and it was going over 1, 2, 3, 4, 5 to 3.3 volt. 1, 2, 3, 4, 5. Okay. Notice that it is white, right? Well, that's because I've got the R. So let me just go back to Visual Studio Code here. And we are going to open. Did I create a workspace on this Circuit Pi drive? No, just the VS Code so far. Okay, so here, open file, and Circuit Pi, and open. Okay. Just doesn't want to. You think of it as bend. Here we go. Nope. A little bit of a balancing act. There we go. Okay, so upstairs here, we need to use the 35 without the R. So we take the R off over here. And there's another place for the R, I believe. Okay, so we're just doing the 1735. Now, I don't know if this will work. I may have to play with pins here. Display 17. Okay, 4-wire display. Come on, can't you just guys stay straight? Okay, I thought you just had to change that. I thought there was 2 places I had to change it in. It might be that AO pin that I got wrong. Green and yellow. Did I get the colors actually wrong on here? AO is green. Yellow went to DC. And blue went to reset. So yellow should go to reset, and orange should go to skipping one. SCL. And orange on here is going to CS. That's not right. We got one. We do have color problem here. This is not right. This one. Orange is going to CS, and purple is the clock. So reset is supposed to be yellow. That's correct. White should be CS. So CS is orange. Maybe I did have it right. And then purple being the clock. Just let me count pins here. Make sure I got them right. 1, 2, 3, 4, 5, 6, and 7. According to this, 1, 2, 3, 4, 5, 6, 7. GP11 and GP10. GP11, and then up one is GP10. So GP11 being on this one is green, and it's going over to SDA. So blue should be going to SDA, correct. And orange should be coming off the clock, 11. And no, GP10 is the clock. Right, okay, 11 then 10. It's going backwards, okay. Okay. Should be right, but we've got the white screen, which is a sign that it's not right. Okay. So this guy here, from what I read on the net, this is supposed to be a 7735. I might be getting that wrong. Let's just open the console. Let's see if there's not an error or something occurring. Control C, Control D. Well, it's not working on the 7735. This could be a 7735S. And if I'm not mistaken, I don't know if there was boilerplate code for the S yet. Yeah, see, there's a squiggly under the S. Doesn't exist. So 35R. So there is an R in here. No module name, add a flute display text. Oh, okay. Duh. Why not? Okay, F1. Available libraries. Text. Nope, not test. Text. Display text. This is a new board. I forgot to add the libraries. Ah! William, you do ST 77. Here we go. We'll take this 35. F1 boards. I'll take ST 77R. And what's our other one? F1. Do I need to display IO? No. We are in business. There you go. I just forgot the libraries because it's a brand new board. Looking in the hard places before I was looking in the easy places. But there you go. There we go. But you can see the sizing's not right. So this is a board that is 128 by 128. So let's fix the 128 by 128. And that is down here. 28. 28. 28. And 28. I don't think there's another one in there, is there? Control S. Not bad. We still have a problem. This one is too big. Let's make this 100 by 10 down, 120. Let's say 124. Control S. Okay, so you can see a fat green block that way. Let's say 90. Control S. Really fat block. And I think our start coordinates are off. Start and stop coordinates are off. Was there a spot for that? 128, 128. Display color map. That was wrong. 10, let's say 15. That's a little better. But you can see the REPL behind the screen. It's right there. The little letters right going across the top of the green. So we're not starting quite right. So with this is where I found that 128 was a bit of a lie. Let's leave it the width okay, but I think the height's wrong. and see what happens. That's better. See, notice the letters are gone now. So it definitely, this is more like a 130. Now the square box in the inside, that was this right here. So let's say 120, Control S. I'm not sure which one is going to be the right one. Well, okay, our green box is completely in, but our width is wrong. So let's say we increase it. Control S. Nope. Let's say 100. Can't tell. Oh, the text is all fitting incorrectly now. Let's say 105. That's better. We're starting to get there. 110. There we go. Not bad. Let's say 115. Nope. The right side's a little more skinnier than the left side. So, well, that's a nice balance. Now the bottom's not quite right. Let's say 22. Yeah, we're off the bottom. So let's say 18. Here we go. Not bad. It's all within. The green is blocking everything out. But there goes another TFT display set up correctly. So, 2, 4, 6, 7. Now, technically, I could set this one up here. This one here is 240 by 240, and it is 7789 is this one. So you notice that in the code here. Let me just switch to so we can all read it a little more. So if we go here into Visual Studio Code F1, the libraries, ST77, there is an 89 in there, right there. So we could do this one. Interesting enough, this one is missing a pin, I think. So we got ground, we got VCC, we have SCL, SDA, we have resist, we have DC. We don't have a CS pin on this one. There is no CS pin. Interesting. This little tiny one, 1, 2, 3, 4. Let's see, 1, 2, 4, 6. This one is 8. So this one does have a CS pin. This pinning on here is exactly the same as, like, say, this pinning on here. So these guys are actually pinned identically. But this one here, if I remember, this is the S one. It has this. It says S on the back. So, but I never saw a boilerplate code for the S. Right? And then that leaves this round one here. So this round one is also 8 pins. So, but this chip here is not any of the 77s. This chip, according to the back on here, is GC9A01. But I did find Toddbot's code GitHub with a sample code for this one. I'll have to try that one out. Not this guy here. Where did I see that? No. Yeah, here. So This is Toddbot's GitHub. You can see it right here, Toddbot up in the top. So this is basically the same idea, as you can see. Now, one thing that you must have noticed, I'm in breakout boards for this one. For this, nice thing about these guys here, these breakout boards, they have like the little buttons on it for resetting the board. Like normally, Pico does not have, or you can see it on his diagram right there. Pico, oops. Oh, right. Wrong display. You're not seeing this one. And Chrome 2. Let's see. Properties of Chrome 2 should be. There we go. And it's now visible. There. See, he added a little push button right there on the breadboard. That's the equivalent of the reset key. So there are Pico clones, knockoffs, that actually contain the reset button. This particular pink one, I got it because it's pin for pin perfectly matched to the original Pico, but it's USB-C, not. And I really wish that Raspberry Pi would do a revision on the Picos and just change the end connector. But in our bin of many RP2040s, so I mean, this is the maker one, for example, and you see we have extra buttons here. So there's a user button here, but there's also a reset button here. So this one, for example, 2 stemma ports, 2 LEDs, whole bunch of stuff, a sound switch. I think there's a sound thing in there. Yeah, there's a buzzer underneath. This thing's like a souped up version. Now this guy here is the Wemos. Now this is another one that is actually pin for pin. It does match the pins based off the diagram here, right? So the real key is this side of the diagram. A lot of the clones, and I have one right here, for example, this guy here, right? They're wrong on this side. They got the wrong pinning. Or at this side here. It says VBus, VSys, ground, 3 volt, 24 ADC reference, and they're not matching up quite with it, which is sad. Feathers always follow the same pinouts. I got this one because of the display, but I do really like these Maker ones. These are really cool. These Maker Nano RP2040s. Although I think when they were building these things, they could have used a smaller crystal. They didn't need that big of one on it. Because everyone else who makes these boards manages to do it without such a large crystal. So this is the Pico's crystal. This is theirs. Really. That's such wasted real estate. But that's it. That's the TFTs. Oh, extra makeover. So I'm going to try the round one a little later. Not tonight, but probably next weekend or something like that. See if I can get this one going. I'm all ready for it. So let's see if we can get test code. Yeah. It's like a tree that moves on its own. But we'll close this editor off. File, close workspace. No, I haven't saved the workspace for this, right? I don't think I have. Nope, I didn't. Okay. So I'm going to create a workspace for this one. File, save workspace as, and I will call this RPI Pico. And we'll save. There we go. Now what we have is a workspace file created down here. So Now I can say File, Close Workspace. And then, of course, in File Explorer, we want to be nice to the file system, so we're going to safely remove, like so. And then we can just turn it off. But that's Sunday evening for you. That's what I was fiddling around for last weekend and a bit on the weekend before, too. It's just seeing if we can get all these. So I spent like several hours last weekend just troubleshooting the chipset, the code, everything. But I think I've got a handle on it. Next thing I try with the code, of course, is to do more than just say hello world on it. Now back to this guy. This guy and this guy are variants of each other. They're almost identical, except this guy here has a micro SD card in the display port. This actually has, I think, 6 extra pins pinned out. Most of them go into here. So you can see over here on these ones, the pin rows are the same length as the pin rows on this one, but it's not on this one. They're actually shorter, right? But you can actually see in here, and I've got a note here mapping out all the pins, right? Problem is, you can put this Circuit Python onto this board, but you can't address these pins. They're not showing up. So what has to happen is I got to learn how to build a Circuit Python UF2 file, an updated version of this file to contain the extra pins that this file has. I haven't figured that quite out yet. I'll probably start with a simpler project, which is really, can I build the UF2 for the Pico? So I'll have to get there. I found the instructions on Adafruit how you're supposed to build those files, right? But I need to set up the build environment and everything for it. Like, it was a lot of work getting the debugger to work on the Pico because I had to install a whole bunch of things just to use that. And my understanding is I'm going to have to use that knowledge and take it a step farther in order to build the UF2 for this. So we will see. And that is it. I'm going to leave you to your Sunday.